thank you very much again. It's an honor and a pleasure to be here tonight and having the opportunity to talk to you and describe what we are doing in our studio, in NYXO studio. It's a great occasion again to share knowledge and to share methodologies and to again improve in general the knowledge about architecture in general and what we're doing. Let's say briefly, I introduce myself. I'm an architect. I studied architecture in Italy, in Venice, and then I moved to Vienna. But I prefer to consider myself, I like to talk about myself as a designer in a broader term. So in a way that design is something that is, you know, a way to bring knowledge and connect knowledge together and enhance the potential, the possibilities of us as human beings to make a better life for ourselves. And so in our studio, so because I'm here to talk about the work of NYXO Studio, that is the studio that I co-founded with my brother Michele, we touch different let's say fields of design, from architecture to product design. But tonight I want to focus, let's say, on our recent researches in design, in architectural design. And I wanted to title this lecture, this presentation, designing the ConFusion. Specifically, let's say, kind of bringing it together our experience and explorations touching algorithmic design and novel manufacturing technologies with a specific goal in mind. And our goal is to kind of create devices that are able to incorporate the surroundings, incorporate in many ways, incorporate the surroundings in terms of the environment, climate-wise, the landscape, and also culturally wise. So the idea is, again, creating kind of absorbing architectures. This is what we call. And again, why the ConFusion? Because the ConFusion for us, it's an interesting definition. It's coming, if we analyze etymologically the word, it's coming from Latin confusion, confundere, that means mingle together. And again, it's crucial. This idea of you know, bringing things and taking things that are different and then fusing them together. And again, also the Italian word that is confusione, if we literally translate it, it's composed by the con, with, and fusione, fusion. So it's with fusion. And this is kind of the approach that we tend to have and we try to have when we design. So to confuse things, and that could be in a sense that, again, to bring things together and create this idea of connection in a way also. And you know, for biology, it's very inspiring in this case. When we see a picture or animals like those, an example of a mimetic crab, that is hosting on his shell, on his exoskeleton, let's say, different or things that are coming, things that are part of the system, of the surrounding. So the crab, in this case, is kind of a carrier, is part of the system, and is also mimetized in it, is the system itself, and is part of it in a more blended manner. So it's not just part of it because it's part of a series of cycles that are food cycles, but also because it's kind of creating this continuity between the surroundings and itself, and again carrying living organisms and other typology of matters. If we think about architecture, there are examples obviously that are going in this direction, and I love to point, for instance, the traditional ancient architectures in the region and also Northern Africa, like for instance, in these cases of the Great Mosque in Mali, the city of Bam in Iran, Saiba Oasis in Egypt. So examples that are talking about this blending mode, this way to where the constructions, the built environment is actually kind of continuous with the surroundings. And in these particular cases, the thing that is the connector, let's say, between the building itself and the surroundings is clearly the material. So there is a materiality that is part of this course, that is fundamental, that is very important. And so I want to talk about this idea of embodiment in a way, or blending or tentative, of blending the buildings in their environment with some projects. We're going to start with a large scale and then we're going to touch a medium and a small scale for this topic. And I want to start with this project that is called, we call it the diffused office. It's a project that is using, again, two things: algorithmic design in a way, and 3D printing technologies all together, to with that goal in mind, the goal to blend the object within with the context environment. I'm talking here all about projects that are meant and designed, let's say, for this region, for the Middle East. And since I moved here, 3 years ago, I'm kind of, fascinated by this surrounding, the desert, and since day one, I wanted to, kind of relate to it in terms of I wanted to talk about the relationship between the buildings and this, specifically this environment. Also because living in Dubai, it's for me like being in a diffused spaceship. So this is what I like to say about this. And what I wanted to do, I wanted to kind of, okay, using these technologies, again, a way to design with algorithms and 3D printing technologies, how can we use this to kind of recreate a connection with the landscape, this desertic landscape? So in one level, it's about the materiality. And when we designed this project, we had in mind, 3D printing technology that is called contour crafting, that is basically stratifying layers of material emitted by a nozzle, material that is in a form of a fluid form. And here, the possibilities and there are different materials that could be used. For that one, we started to think about Adobe, kind of a specific kind of Adobe, to use it as a material to create scaffoldings or walls, let's say, that are acting as scaffoldings. And what I like from this technology and technique also to manufacture buildings, let's say, components for buildings, is the roughness that you have at the end. That is, for us, an extremely interesting aesthetical component. Again, fundamental for this idea of embodiment and absorption. I like to say that these buildings could absorb the context through the materiality. And the fact that you have this stratification of layers, but we will touch that soon. On the other side, I was looking also to the vernacular Emirati architecture that was using date palm to create enclosures. And I was fascinated, we were fascinated when we talked about, how to treat and how to deal with this, or how to treat the facades, how to generate the walls of the building. We were fascinated by this striated pattern generated by the regular configuration of the elements. In this case, and also the fascination was about the fact that these elements are not completely enclosing, so creating a completely opaque wall, but something that is kind of, giving or having interstices between the single components. And this actually has advantages in terms that the breeze can go, the wind can blow through, and so you can have a gentle breeze inside, and it's shading. So there are many interesting advantages. And so we try to understand, okay, can we mix or can we take advantages of these two things and bring them together into a project? And so we started this idea of the kind of expanding the size of the elements to a bigger size in a way. And as you can see here, the idea for this building is to create a wall system that is, again, as I said, scaffolding that has, again, is embedding different qualities mainly, let's say, related to isolation purposes. So the wall itself, that is this extruded system of pipes that are intersecting each other, is actually hollow. So you have hollow pipes that are articulating the wall. And this is creating, because you have, the lower level, they're detached from the ground, so they're creating some wind flows. They're channeled from the top and the bottom. So basically, you have the possibility to create these air chambers inside that are isolating or helping to isolate the building from the high temperatures that you can reach during the summertime in this region. And this is the first reason why we thought to kind of, again, expand and expand the circles and to intersect them into a cohesive system. And at the same time, they are creating the spaces to cast the concrete, and so to have the structural component incorporated into the wall system, so that you don't need anything else than themselves. I mean, these pieces placed in a specific position, and then you have the columns, the concrete columns that are connecting all of them together. But the embodiment is not only in terms of the performance, so the performance in terms of the isolation or in terms of the structural performance. That for us, it's it's important, but it's relative. There is also, as you can see here, a third level, let's say, of embodiment. That is the embodiment of the opening system. So that means that what you see here, the facade has this series of pipes that are actually moving or that are adapting to generate, to create the openings. But let's talk about that in a second with a better picture. Again, this is a way to represent how we like to, or we tend to kind of analyze also the way to build in a concrete manner, so in a practical manner. And in this case, the building was thought to, or was designed to be split and divided into chunks that are manufactured in situ, possibly, as you can see in the picture, with a series of robotic arms, and then directly move to the place where you need to have them, and then cast the concrete in the cells that you have. So this is also a way to represent the way you can manufacture the entire envelope or the entire building. And this is what I was talking about before, and also the sequence. In this case, the algorithmic design is used to kind of manage the complexity of the facades, and the facades are the skin, is the skin of the building. The building itself, it's just a volumetric object, and the entire technology here, in a way, if we can say that, it's directed to the cladding system, to the facades, and in this picture, what you can see is the transition from the first stage, the one on the left, that is a simple plain iteration of the tube of the pipe through the wall, and on the right you have different tests for different opening configuration. Another thing that I can say is that to articulate the openings, actually we were also we were inspired, let's say, by traditional Middle East architecture, in the sense that the architecture that works with narrow openings that in that way are able to stop the sunlight, and to bring inside only indirect light. Also because it's dealing with the width or the depth, let's say, of the wall itself. So we have these openings that are narrow and depth, and the depth actually is helping to screen the sun from these facades. Also because the strategy of the building, and we'll see that, again, is inspired on many levels on the way, let's say, the traditional architecture is dealing with the building configurations in cities in the Middle East. Another thing, another level of understanding is the way the streets are organized, in the sense that you have narrow streets to profit of the mass of the building, to generate shadows, to protect the streets from direct sunlight, and also to create wind flows in between, so to have a breeze of fresh air inside. And this was used as a generator for the entire building. So the entire building is not a single piece that is operating within the entire plot of land as a single object, but it's actually subdividing the plot in pieces, in parts, to kind of recreate this idea of narrow streets or narrow connections. Also because what we wanted to develop for this project was to a balance between the indoor and outdoor spaces. Here, during the winter time, or in the, let's say, in the mid seasons, it's amazing to enjoy the outdoor spaces. So it would be a pity not to design a building or that is not creating a relationship or is not recreating a pleasant outdoor space. And this was also a driver for the configuration, the general configuration of the volumes. But then we used also the sun radiation to control that. So in the sense that the masses, the heights of the buildings are controlled by the sun radiations. And at the same time, also the facades are controlled by the sun radiation, in the sense that you have this kind of opaque facade with these slits, these narrow openings, only when you have direct sunlight that is hitting the surfaces. Instead, the other areas, the other facades are actually glass facades, as you've seen in the main picture. So there is a play, a game between, or an alternation between opaque but with facades with narrow openings and the complete glass facades, so that are taking advantage of the position to then bring inside an indirect light. So again, this fragmentation works to or kind of trigger different experiences outside. Unfortunately, I can't show you the video. There wasn't a video about the articulation of the system, but no worries. So from that project, I want now to, that is again dealing with 3D printing, algorithmic design, to control and manage the complexity of the system in terms of again connection with the context on different levels. I want to show you now a smaller proposal, a smaller building that again is dealing with 3D printing, but in in different context. The previous one is in a urban context. This building here is it's an observation tower. The project is titled Supranational Concreation. It's a small tower in this case that is placed or is working, let's say, in a totally completely different environment. We're in a natural reserve, and again here the sand and the desert are playing a big role in terms of the again in the quality, the material quality of the building, not only in the concreation, or let's say on the creation of the geometry, but also in the materiality. Again, we strongly believe that you know, this technique, this technology like 3D printing of contour crafting and so on, they have an aesthetical quality, and so this stratification that is actually intriguing, and we can use it. And when I say that the building here is absorbing the context, it means also we kind of consider it in a literal way, in the sense that the fact of having these layers, you know, that are composing the buildings, is creating a second level of porosity. So there is a first level of porosity that is done by the material itself, that it could be, you know, it is not smooth or glossy, but it's something that has a you can perceive the granulosity, the granular quality of the surface, but there is also the stratification of the layers, and these things are actually creating the opportunity to absorb the context in a way that when the wind is blowing, is carrying the sand particles and is hitting the building, these are captured in a way by by the structure itself. And so what you have is an incorporation again of the surrounding, the materials that are composing the surrounding. So the building, we tend to say that in this case, it's the context, or is part of the context. It's an actual active part of the context in this manner. So you don't have, like, we're kind of critical about the use of, for instance, glass claddings in this context, no, because you know, then what you have is a building that is designed to be clean and perfect, and then it becomes dirty, no? And dirtiness in that case, it's not a value. Here, what we're trying to do is, let's say, to transform dirtiness in a value. And so the language is, again, similar to the previous project, because what we wanted to do was we wanted to try to transform what before was a wall or a wall system into a structural component, or a component that is able to create a relationship between an inside and an outside. Or even if the tower itself, it's an outdoor space because it's not enclosed by anything, it's but the column, the system, the system of these columns was designed to create this interaction between inside and outside, and also a transition between them. We started to analyze the main element, let's say, of an observation tower, or what we think, or we were thinking is the main element of an observation tower, and obviously it's the observation deck, but we wanted to create an experience, and the experience is also in the way you ascend, the way you move in the structure to reach the observation deck. So we started to design the objects through the spiral staircase, and the spiral staircase is creating or organizing the system itself. Organizing the structural system, and the structural system is embedding all the parts that are necessary to sustain the various components. For instance, from the same column, let's say, that is distributed around the object, then you have buttresses, you know, that are branching out to sustain the steps of the staircase, for instance. So everything is embedded in this way. Not that it's part of the system. It's not something added, but it's part of the system. We're talking about the main thing. obviously, when we talk about a building, it's kind of impossible to say that everything is one thing, but it's obviously, when we talk about tectonics, it's about the relationship between all these components of this part. And we're all obviously conscious that also for an object like this, you have different components, and you'll see also in the other images that some parts are 3D printed and some other are manufactured in different ways. So there you have steel beams and a wood deck and so on. But the point is that here, again, we use 3D printing and algorithmic design to kind of incorporate some components together, so to create this bond, this connection. And as you can see here, these are the first sketches now that are distributing the helicoid, the spiral staircase, the spiral steps, and this attempt not to create a connection from the edges of one step to the reciprocal on the other level, so that we have a kind of again transition between one level and another one. And then this the articulation of the staircase is generating the inner structure and the outer structure as a kind of two layers, two filters that are talking to each other, and are creating this, or encapsulating also the staircase. They're creating an indoor and outdoor, or the differentiation between the two, let's say. But obviously, again, at the same time, we call usually this for us is a virtual object, in the sense that virtual in the sense that we can simulate directly not only the logic of the system, but also the physical manifestation. How? So what I said before, from one line that is defining the trajectory of the system, you have the physical manifestation of the pipe that then is transforming in terms of the section, and is becoming also the buttress that is then in this case now sustaining the steps. So if you follow now from the bottom, from the ground, now you have a circular element that then is deformed to and is elongating to become a structural component of the staircase. We said it's a virtual object because here we can try different configurations, and actually this one is a small tower, but with the same logic you can actually modify the algorithm to generate easily, I mean, just a few parameters, and redefine the articulation of the for instance of the diameter, and so the staircase and all the elements that are composing it. Here we wanted to have something that was compressed, compact, and we started to, and this is something that we do usually. So this is not a final rendering or a final visualization of the object, but it's in between. So we needed to kind of have in mind the mood of it, and this is what also was referring to before, something that is kind of a concreation coming from the environment, is growing directly from the landscape, from the ground. It's the same granular quality and so on. Although, I mean, it's an expression of kind of, on a type of controlling, the geometry itself. These are some, an elevational section to understand the relationship between the outer shell, even if the shell is not correct in this case, the outer grid, or let's say fibrous structure, and the section of the beginning of the tower. In this picture, for instance, you can see how it works in terms of the promenade, or the movement, the motion that the movement that you have to do to reach the deck, the upper deck, so that you're at the beginning, the first part outside the building, and you have the tower, let's say, towards the center of it, and then slowly in the middle of it. And so here you actually entering it. So it's a transition in terms of, so it's a motion that is moving you from outside to inside within the same system and through the same system. And through this section, you can see the inner, the core, that is a void that is connecting the building from the ground to the top. Again, even here, we analyze, let's say, the fabricability or the way you can fabricate and manufacture the component, the pieces, aware now of the limitations of the technologies in terms of the size of the pieces that could be handled, especially in this case, because the idea for this tower is to be built or to build the pieces in a factory in a controlled environment, so where you can have also a quality control on the material. And then you just assemble the pieces on site. And here you have the subdivision of the pieces, and also the some details now talking about that when you move the pieces, you must maintain the membranes, for instance, for this kind of structures, when you have pipes now that are detaching, and then you remove it when you connect all the pieces inside. Some details of the constructions. And this one is the sequence now, the fabrication in the factory, the moving the pieces into the construction site, and the assembly that is happening quickly. Actually, the advantage in this case is that when you have the pieces printed, you just have to move them in the site, and you can assemble the entire structure easily. Some pictures of the entire system now with the array of components that are distributing around and also again the interrelationship between the 3D printed part and the other materials that are like steel beams or the steel structure of the deck, and the composite wood for the steps, and so on. A view from the top of the and a view of the deck. Changing scale and also functionality from buildings to urban devices. I want to talk to you about another project that is called Urban Fossils. And this project is about, again, talking about the way we can enjoy outdoor spaces here in cities like Dubai, Abu Dhabi, and so on. I was very fascinated to understand and kind of use, again, 3D printing as a technique to generate objects that are able to refresh areas, outdoor areas. So we changed, obviously, I mean, for this project, we changed technology in the sense that it's not a contour crafting technique, but it's a more 3D sand printing. So it's using sand and a binder to 3D print with a higher accuracy and a higher level of details, as you can see also on the picture on the right. And we started to imagine these objects inspired by the fossil dunes. And so what we wanted to do, we wanted to create a logic to generate a series of objects now that are similar but different. They have a specific configuration, but with the same, let's say, genotype, so that is creating the object. So we just set it up a simple algorithm that is growing layers on top of each other. And these layers, they are distributing modules in a way to obtain a porous volume. So as you can see here in the middle picture, you have the object cut in different heights. You have and you see the inside as a porous element. here, okay, there was the video of the stratification, but you can imagine, let's say, the module that is a simple prism replicated over and over, connecting them, one to each other. And the advantage of using algorithms to generate these forms is that you can, with one single piece of software, you can generate a multitude of configurations, and each configuration is specific in terms of the performance in this case, because in a minute I tell you the functioning of the object. But generally what we needed to have is different ratio between the mass, or let's say the solid and the void, so the density of the object, but also the different heights. As you can see here, you have different series, and for each series you can have different heights, 250, 280, 310 meters, and each of them has a different mass volume and a different ratio between the total volume and the mass volume. Basically here, the idea of the object, again, it's an hybrid. It's a passive cooling system that is inspired partially by the highest chamber in the Middle Eastern area. So every component, every object that is here, and that you can see here, is on top of a water tank. So, and the position of the water tank that is underground is helping, let's say, to have a cooler temperature for the water. The water is pumped up on the top of the object and distributed through that pipe, so that it's dripping down simply by gravity, and through the porosity of the object, through the pores, through the voids of the object. So basically, this system is, and the porosity of the object allows the wind to flow inside, and through a process of evaporation, basically, it has the property to cool down the air. And so hot air that is passing through is basically slowly and gently cooled. And so here to say that obviously the position of this object, because we analyzed a specific piece of land in a urban context, but this is what we wanted to do, to analyze it in a urban situation. So we analyzed the wind loads during different seasons, and to kind of summarize them into a general map that is used to guide, let's say, or used to guide the design process and to place the clusters. So basically, these objects are organized in cluster with different heights and so on, to being also at the same time kind of urban furniture, a decoration for the urban environment, a kind of a sculptural element, in the urban environment, but it's at the same time, a fountain, but also a cooling device. So something that is synthesizing, again, different functionalities in a single object. Again, here I had a video showing the entire system, but okay, there is this picture that kind of is giving the idea of the configuration of these objects for a urban a square, a plaza, or common or outdoor spaces. Staying in the urban environment, in the outdoor, this is kind of an obsession in this period. And this is a very recent project that we developed, that it's ongoing. It's called Urban Blossom, and it's a system of, before it was a cooling device, this one it's a shelter slash shading device. We tended to generate a kind of a system that is adaptable to become many things. It could become a bus station, could become a lunch, an outdoor lunch area, it could become a covered playground, and so on. So what we tended to do here is to define the system. And again, here is going, this system is using 3D printing, but again, the previous technology, so the contour crafting, with geopolymers and using sand as main material and geopolymers as binders. Here, the idea was to, because we don't need actually a complete, in this region here, I mean, we don't have the problem of rain, no? So that we don't need to cover from rain. So the idea was to create a shelter, a protection from the sun. The idea is simple. It's a column-like object that starts with a compacted section that is slowly enlarging and expanding to reach a wider area now and protect now by the sunlight. I mean, this, through the unfolding system of the branches. And this idea comes from also the technology itself, because we're pretty, I mean, well aware now of that we can't generate horizontal structure without supports in a continuous manner. No, if you want to make this or work in an efficient way with 3D printing technologies. No, so that means that we have a continuous production system without interruptions, and so we control the size of the object to make it with one single robot, and the continuous fabrication from bottom to top. Obviously, at the beginning, you know, the idea is to, I mean, was to again create these branches, you know, from this simple cross-like starting point. And initially, or at the beginning, the idea is always how to say, or the first. This is the first manifestation. It is pretty complicated, not complex, really complicated. And these are some of the initial configurations. Again, this, you know, from it's always interesting, you know, the process is generating new things, and we can take, we're now thinking how to use some of the qualities on a small portion of it to actually expand it into another project. But is to say, you know, that actually the way to use also algorithmic design is to manage in the intricacy of the object. And in this case was to manage the complexity of the branching system. So what we tried to do is to analyze the single element and optimize now the form of it, the formal deformation from the bottom to the top. And here you have some of the manifestations now of the single element. But then when we had a clear idea about how to control the single element, we started to organize the system. And again, it's it could be implemented. It's a system that could work in an implemented way, so that you can add pieces, and automatically it's adapting the others, the previous and the new one, to the new configuration. Here, I mean, there are just 4 elements, but they're creating these spaces in between, and at the same time, so there is an articulation from the bottom to the top. So this expanded area now that is defined by the circles. So it is actually the area, the printable area by a regular robotic arm. And but then at the same time, we have the generation of the pockets, of these elements that are actually, again, creating the opportunity to have this object not only as a shelter or as a shading from the sunlight, because these kind of branches are actually kind of screens, no, that are or surfaces that are stretching not to screen the sun. But at the same time, they're becoming pockets to contain something. And as you can see, the holes that are here are not by chance. I mean, there is a reason because of these holes. And let me show you the reason is that to create a vertical garden, or better, or a garden on top of these objects. And the connectors are actually to connect the water tanks that are in sitting area, through the structure itself from a capillary assembly. And the idea for this project is to embed nature in the object, local plants, local vegetation, into a way that is becoming again a green roof for urban areas, like you see in these structures. So to kind of reconnect the natural environment with the urban one. So imagine this really as a diffused system, not to bring then not only the plants, but also not only the flora, but also a fauna related to the flora, the specific flora, and bring people together, or gather people around all these pieces of let's say hybrid nature in the city. Also because the idea is to, and now what we're studying, is the possibility to transform the surface itself as a climbing surface. So the form of the surface itself as a way to help the plants to distribute themselves also in the surface. In some typologies of plants, obviously, not all of them. And so that you have an entire, let's say, a green object. But this is, again, it's an ongoing process. And also the configurations of the sitting areas that are connecting them and so on. But it's a completely reconfigurable system. I want to conclude, let's say, in a way that is going from an interaction with the landscape, with the environment in a natural, let's say, with nature. So the building that I discussed, or the buildings or the device, the urban device that I discussed till now, they were kind of reconnecting or trying to reconnect, let's say, the landscape or the environment in terms of the nature of the environment into the building. With this one, I was intrigued to kind of work with the cultural environment. And so in my walks here in Dubai, I'm fascinated by the use of geometry, the use of solids in the architecture. And that is kind of, I mean, traditional and something that it has, it's the base, of architecture design. But I was extremely fascinated by to use something or to understand, let's say, or to start to understand, let's say, the language that I found here in the region. And I wanted to analyze one of the emblematic elements of Islamic architecture, that is the Mugarnas. And I started to kind of investigate on traditional architecture, like the Queen Mosque here in Turkey, in Bursa in Turkey, or modern interpretations like the Hatem Mosque in Alexandria, Egypt. And I was really intrigued by the use of the, but not, for many reasons. And one reason is that there is a debate now in some, let's say, schools of architecture talking about the value of the module or the modularity in architecture and the discrete architecture. So the possibility to work with a module that is repeated over and over to create a complex system. And then I said, well, it's nothing new, obviously. Well, if you go back to the 60s, and Breuer started to work with concrete modular objects, architectural objects. But again, if we go back in history, in architecture history, we have these examples, magnificent examples in traditional architecture. So I wanted to try to investigate and analyze it by myself. So I started to recreate the geometry, so the module of one typology of Mugarnas and its fractal or its iteration that creates these very articulated compositions that usually are the transitions from one state to another, so the squinches in this case. And I wanted to kind of use it as a bigger architectural component. And as you can see in this example, I started with the single component that is coming from the previous analysis, and I started to use it in or rotate it around different axes, and I started to discover, let's say, the potentials of this module that is actually capable of articulating very different forms. And again, a simple element, simple if we can say, the iteration and rotation of this element in space is actually giving the opportunity to articulate spaces with different qualities. And I was really fascinated by all these, let's say, configurations. Again, this is still an ongoing research, and I'm going to show you, let's say, some of the initial results that we had in this first phase, let's say, but also, let's say, also the first step on the second. So, for instance, in this case here, you see the module that is taken from the original one, and then we try to stretch it in specific directions. So to use mathematical transformation, simple mathematical transformation like scaling processes, to generate a second level of modules. And as you can see, the module A family, now that is this 1, 2, 3, and 4. So through the combination of these 4 elements, started to play around and to connect them, and this is what happened. So basically, we have these different configurations, and there is again an extremely interesting potential in the use of these elements now in the aggregation of these components to generate this. I see proto buildings. And the fascination, I was really fascinated by the relationship between the voids and the solids, so the volumetric object and the void in between. So this tension between these two elements, especially in moments like those ones, that the wall is changing thickness now here, or enlarging like these spaces here and creating opportunities to have more intimate spaces. So for instance, you have the alternation of open spaces, open rooms, and then these enclosed volumes. So we wanted to kind of verify these ideas into let's say a concrete project. So we said, okay, let's start with the idea of a villa, of a so small architecture, a house. And so we started to organize this element into what is, for now, the first Villa Mugarnas, that we say, that is this first configuration. But again, the potentials are manifold, because you can rearrange them in many different ways. And there are interesting moments like the openings, like this door now that is having the same little, the arc, or again, these surfaces that are creating the tension between and the division, but at the same time the connection between different parts, different spaces of the house. And so we're still investigating on the special qualities that this technique is providing. So to expand and enlarge these geometric elements now into big architectural components and working them as Lego parts. To conclude, what we're doing now, so we wanted to kind of, so we kind of saw some similarities, in terms of, we were fascinated by the work of Rifat Chadiri and his buildings in this modern architecture in Iraq. And these masses, the work of these masses and these geometrical elements. So we wanted to kind of use the same ideas of these components to kind of change scale. So what we're trying to do right now is to use algorithmic design to organize these components, these chunks, and through a series of rules of engagement, let's say, so of connection between the parts, we're starting to analyze the possibility to have, let's say, or define stories with the specific qualities. and in a way that are generating kind of interesting tensions between, again, the mass and the void. And so outdoor spaces versus indoor spaces. Again, outdoor spaces that they have the quality of an indoor and so on. And you see here some of the configurations on working on 2 levels or on 3 levels on a row and so on. And what we're doing now, or let's say the ambition now, is to introduce some machine learning techniques to automatize also the investigation and the way this system is creating the connections between the components, also to control it. And to this is, you know, this phase is more or less like the phase that I showed you before about the previous project, where you had the kind of a messy result, but still with some level of control. But now with this project, we're at the same level, so that we need to bring more rigor, let's say, to control the connection between the elements to generate proper spaces in terms of usage, in terms of functionality, basically. And these are some, some of the results that we have now. And what I'm trying to see here is a condo, is a building where the size of a person now is half of the unit, more or less. That's it. This is the journey through a series of projects talking about this relationship between algorithmic design, 3D printing.
Thank you. Thank you, Mirko. We already notified everyone if they can share us their questions, if they can send it now. I believe you're already in Instagram. We can see plenty of other projects, right?
Yes, yes. There are some projects. Yeah, in Instagram, obviously, we have a collection of the whole production that is including also product design, and so we space it's between, as I said before, between different fields, scale for the projects, and typology, from Syria products to one-of-a-kind object, or let's say research projects. So we tend to kind of diversify also the investigation, because we believe strongly in the cross-disciplinary approach, where you can interfere, let's say, or create interference between the disciplines and the knowledge. So what you learn in one field is then, it could be then used in the other one. And that's the reason why I prefer to kind of define myself a designer, in the sense that then is taking into consideration the whole range, of possibilities when you design something. And I mean, it's an ambition.
Yeah. So we have a question from Mustafa regarding one of the first projects you show us, where it's a 3D printing. It's like 3D printing about with mud. I'm not sure. Can you elaborate more about the 3D printing technology in architecture?
Yes, yes. There are many technologies that could be applied in architecture, and actually we have experience in product design in the application of 3D printing to functional objects. Right. So what we wanted to try with this project to start to think about how we can use 3D printing in the architecture field. And that project that I showed you is one of the first. Now we are also talking about, and again, you can use different technologies, and you can apply different technologies to architecture. That project was talking about the application of 3D printing to make the skin, the wall of the architecture. And it's using, yes, Adobe MUD in that case. Now, again, let me open a parenthesis. We can classify, let's say, mainly two techniques that are feasible, let's say, on an architectural scale. One is the we can call it, I mean, it's a contour crafting that is similar to FDM in a smaller scale. So you have a CNC machine that works in 3 axis, and then is emitting a fluid material on layers. This fluid material is a crucial component of the technology, in the sense that now we have the possibility to work with different materials. One of the most diffused, or one of the most used, is concrete, obviously, and we're talking about special concretes, very thin in terms of the composition, and or fibrous concretes. But again, there are other possibilities, like the use of again mud, and in that case we were combining again the use of Adobe with as a material to make the structure, but then the structural component is not the wall, or partially the wall. I mean, it's a collaboration with a traditional concrete column now that is poured inside. So this is one way. Then there is the possibility to use the concrete, or for instance geopolymers as materials to build structural components. And here, I mean, there are interesting ways to deal with it now, and to work with. What we try to do also with the project that we developed is to create an aesthetic for the technology itself, and also to kind of, you know, don't imitate traditional ways of buildings using 3D printing, but we wanted to use 3D printing in an original manner, so in a manner that is expressing the quality of the technology itself.
Okay,
Sorry.
Yeah, we have Dr. Rasim Badran. Dr. Rasim.
Yeah.
Yes.
Well, thank you very much for the very nice presentation. I missed the beginning, but I am now more interested in the last model of the Mugarnas and Mashrabiyya, and Mugarnas, I mean selectite. So you tried to start experimenting in the curved one, in the hypersurface. Did you do any exercise on the folded triangular Mugarnas? I mean, instead of having this curved linear form, to have to use the straight or the folded triangular shape, so that you can create also new model of building, or let's say sculptures.
Yes, thank you very much for asking, actually, because it's again, I wanted to share this project with the community. It's an extremely fresh project for us, and so we are pretty excited. Yes, this is something that we're planning to do. So to use the double curvature that you have on this surface in a faceted way, so with triangulations, for instance, instead of the curvature. And this is the next step that we want. Also, another thing that we wanted to try to kind of see if we just extract the surfaces from the geometry, but because now we're working with the solid, no, so the mass. And the next step would be also to understand what are the differences if we work only with the surface of the geometry. Yeah, definitely. I mean, it's such an again, an open how to say, so it's opening possibilities, and it's very exciting because of that, you know, because it's not a closed system, but a system that is allowing us to explore and experiment, you know, in many ways.
Because I think by using this triangular folded shapes, you can create windows, and you can get solid and transparent surface within the building structure. And I think it will be very interesting. Yeah,
and also for we were thinking about manufacturing feasibility. You know, if you have planar surfaces, it's much easier also to build, you know, in a larger scale.
Yeah.
And so yes, definitely we're thinking to, because now it's in an abstract form, no, because you have also these thin, extremely thin layers that are impossible, no. but in the case of the villa, for instance, we consider now the thickness of the manufacturability. Let's say this.
Yeah. Thank you.
Thank you.
So we have another question from Mariam. As an architecture students, what are the best methods for them to enhance themselves in these methods and concepts of the 3D printing algorithms, etc., that you've shown us today?
Mm-hmm. I would say that the first thing would be to be open and curious. In which terms? When you see something, I mean, this is a general consideration, but when you see something, you try to be curious to understand what are the rules behind what you see. In a sense, what are the dynamics behind the phenomenon? So try to study why what you see is configured in that manner, in that way. So when you do that, you're actually it's a process of reverse engineering, no? And it's a way to really explore what you have as a final outcome. And when you do that, you're not seeing anymore as a final thing, but actually as something that is again. Let me use that again, that word virtual, in the sense that it has the possibility to become many other things, and this is something else that I like. Usually, I like to say when I design, I try to work with undefined objects. So that means that I don't care about the final result, in the sense that I'm much more interested in the process. And so, what is interesting for us is to define a logic. No? And we do that because we try to do the reverse now when we see something, and we try to analyze it. This on the way of the algorithmic design. For the technology is giving us kind of a boundary, to work with or within. Like if we're talking about 3D printing, we must know what are the limits and how does it work in terms of the technology that is used, and because there is a difference if you use a 3D printing machine that it has 3 axes or a robotic arm that has 6 or 7 axes of freedom. And so it's important for us as architects or designers to spend time to and know, or let's say expand our knowledge in how the technology works, because then you're setting up the boundaries, the limits, because creativity, I believe that creativity works better when you have constraints. So if you have the constraints of, for instance, of the manufacturing technology, then you can better articulate the logic of the system that you are designing.
Yes, taking consideration these constraints and limits and the boundaries, and learning these tools, and also despite how fresh, newly in the market, and let's say in the career, and beside doing a lot of analysis, research, etc., how different or longer comparing to normal projects? Yeah.
Thank you for the question, because this is a crucial thing, in the sense that let's say that usually clients doesn't allow you to experiment so much, in the sense that mainly because of timing, because of
money.
Time. And money, yes, true. Absolutely. So what we tend to do is to let's say exploit our as much as possible the time that we have at our disposal to engage ourselves in projects that are self-driven and self-promoted. So for instance, this Mugarnas project, for instance, there is no client behind. We felt the urgency, let's say, to investigate, to know more about this topic. And we started, and we're doing it in the free time, or in the in the in between spaces that were between the projects. But we believe that let's say sooner or later, this thing, because it's part now of our on our knowledge, or partially, or we're still working on it, but we kind of are embedding it, and so we can use it in the next or in one next project, for instance. So what I suggest usually is to, it's like training. It's like going to the gym in the same thing. So you have sometimes to dedicate time to do these things, even if they're not paid, and then trying to maybe, these are kind of concentrations of ideas, this project, and then in a project with a client, you can take a part of it and then inject it into the project. This is the more or less.
This is the only way now. Yes. Okay, so we finished all the questions, and it's already 15 minutes after the lecture timing. Thank you a lot, Mr. Mirko, and for everyone who attended with us today. Thank you.
Thank you. Thank you very much. Again, it has been a pleasure, and enjoy the rest of the day. Thank you.
You
very
too.
much.
Take care. Bye-bye.